Nothing's working. What is going on? Anybody have a suggestion? I can move windows around, but I can't. There I clicked. Let's see. This isn't responding. I can't get this to turn on.
Command Q.
Command Q.
Like that'll do it.
Maybe it's Firefox. Let's see here. No.
Oh, you have to get that plane.
Right, I know. See that, but it's not doing it. No. This is just text. I'm just trying to make it bigger. It's not. And then this. Oh, that's okay. That works. Can you read that? Oh, no one. Oh, no. Everything's working fine. My fault. Got to select. Okay, so here's a rate function. We're back. Okay, so here's a rate function of malfunctioning fridge, the temperature. It's the rate of change of temperature, Rx. And there's the function up top. And here's what it looks like. And the rate is in degrees Fahrenheit per minute for the 15-minute period shown. Okay? The temperature in the fridge at time equals 0 is 40 degrees. I'll put the screen back down. Okay? So I got some questions for you to work together on. I want to describe in general how the temperature in the fridge changes over these 15 minutes according to the rate function. Estimate the first time in these 15 minutes when the temperature returns to its starting value. Approximate over the course of the 15 minutes when the temperature is the lowest and the highest in the fridge. Okay, estimate. Write a function that gives the exact temperature in the fridge over this 15-minute period, and then write an expression in two ways that gives the greatest total increase of temperature in this 15 minutes. Go, so work on this. Yeah. So you're not doing any calculations with that. There's nothing in my questions that involves any calculations for that rate function.
This is and the overall not 8.0. Accumulated temperature. Still it's decreasing and increasing rate, and then it begins to increase. For the first time.
Come back. Don't worry. Don't worry.
Is that the corresponding draft?
Shoot, that's not going to work. That's the rate function. That's the rate.
Yeah. So like for the first maybe because like 13 past 13 it's increasing and then after 13 15
Okay, now it truly shows 15 minutes. So that's what I want. 15 minutes. Okay, keep on.
What did you say? It's like an increase in And then it starts to get decrease. Yeah, the decrease is getting smaller. Yeah, it's decreasing until like 13. Once you get bigger negative, you got like over minus decrease. Yeah, that's confusing.
Okay, I added something number 4.
Oh, yeah. Well, I don't know. The rate's changing, but that's, I don't know, it's still.
Okay, sounds like a lull. So let's say describe in general how the temperature. So I want all new people here get involved. Alexander, number 1. So can you describe in general what you think the temperature is going to do here over the course of the 15 minutes?
There's a one point where it's rising and it's faster, and then it's rising at a slower rate, and then
Maybe let's break this up in chunks here. So in this first kind of part over here, tell me what the temperature is doing in the fridge.
it's dropping.
Dropping. Agree or disagree?
Agree.
But the graph's going up.
Just not rising at a slower rate.
The rate is negative, so the temperature is dropping here. And then starting here, temperature is
Rising.
rising until it gets to here, and then the temperature's falling, right?
No.
Still rising. Rate is positive. And then over here, dropping. So in this 15 minutes, the temperature drops, and then for most of the time it rises, and then it drops because the rate is negative, and then the rate is positive, and then the rate is negative. Okay, cool. Estimate in the first time in these 15 minutes when the temperature returns to its starting value. Kevin? Can't. Brent?
I guess that it's somewhere between like 7 or 8 minutes.
7 or 8 minutes. Why?
Because from 0 to 4 minutes,
Okay.
That decrease
Decreased?
is probably the same as it increases from 4 to 8.
Yeah. Do you hear that? So probably this decrease right here is probably about the same as an increase to about here, somewhere in here. You see it? So it's going to return to 40 degrees somewhere in the 7 or 8 minute range. Does it make sense? Cool. All right. Approximately when over the course of the 15 minutes is the temperature the lowest? Alina, when did you think it's the lowest in this 15-minute period, the temperature?
I was thinking of either the beginning or the end.
So either here or here.
Yeah, at the end it just keeps going down. So
What did we say happens at the beginning? What's happening to the temperature right here? Is it going down or up?
it's going down.
Going down. So is it less at 0 or less around 4? The temperature, yeah. Would the temperature be less at 4? So put a hand up in the middle. What do you think, Aaron?
I was say it's going to be 4 minutes. A good guess would probably be around 4 minutes.
Yeah, this is the point right here in those 15 minutes when the temperature is the lowest. Make sense?
Yeah.
What about the highest? Marco,
On the right.
just give me a number.
13.
By 13, wants this to be about the time when it's the max temperature. Good, right, okay. All right, so we want a function that gives the exact temperature of the fridge over this 15-minute period. So let's call it T of X, temperature function. Who thinks they got that? Let's see. Molly, did you get it?
I did, I don't know if I'm right.
Okay.
The integral from 0 to 15.
Integral from 0 to 15.
Is R of X.
R of X,
Sorry, call R T.
R of T. So do you want to go from 0 to 15? If it's 0 to 15, then we won't have a function, right? We want to get a function at any time we can get the temperature.
So is it
0 to X. All right, is that our temperature function? Austin,
I think we need to add 40.
he wants to add 40. Yep, add 40. Okay, so now, based on, I'm going to put it up. I'm going to put up this temperature function. So I'm going to take this off. And we've got the tools to do this in a heartbeat, right? So I've got R, that's that temperature, that rate function. And so I'm going to come down here and I'm going to graph the true accumulation as 40 plus the rate that I've defined from 0 to x. And then I'm going to graph that on the right side. Well, let's use red. Red for warning, bad fridge, right? Okay, here we go. Outside the region. Okay, so, but that's good because so anyone think they've got a, think they have an image of what this should look like? Draw it with your finger. Yeah, draw it with your finger in the air. And then I'm going to zoom out and you can see how you did. Here we go, here it comes. Now I'm going to come back here and zoom in. No, didn't want that. Just on the X. Nope. Oops. Okay, there it is. Is that what you did? So that's the accumulation function. Okay. So notice where did you think that it would be the lowest? Around 4. There it is. It goes down until around 4, then it starts going up again. Where did you think it would be the highest? Around 13. Okay, one last thing. Express the greatest change. Who can express the greatest change in temperature? Exactly. Brian, can you do it?
Would it be, we do the integral from starting at 4 all the way to 13?
4 to 13 of?
R sub,
Okay, what's another way to express that change? Peter?
R of 13 minus R of 4.
Okay, don't do that on the test tomorrow. Try again.
TA of 13 minus TA of 4.
T, well, I called it T, yeah, so T actually, yeah. T of 13 minus T of 4. Plus 40? No plus 40. Starting at 4, accumulating the change in temperature up to 13. That'll be your greatest change over this 15 minutes. Study. Test tomorrow. Get sleep and eat something before the test too.